Hey guys, and welcome to a new CNCM AME video. And today we're covering the 2020 AOIME problem number 11. Um, I know we didn't finish the 2020 AME 1 playlist, but we will finish that in the coming days, I promise you. And we're starting a new playlist today, which is the 2020 AOIME playlist. And hopefully we'll actually complete this one in the next coming days instead of leaving it, unfinished. But here we go. So the problem reads, let P of x equal x squared minus 3x minus 7, and let Q of x and R of x be two quadratic polynomials also with a coefficient of x squared equal to 1. David computes each of the three sums, P plus Q, P plus R, and Q plus R, and is surprised to find that each pair of these sums has a common root. And these three common roots are distinct. If Q of 0 equals 2, then R of 0 is equal to m over n, where m and n are positive integers, and find n plus n. So before we start, let's just write out all the quadratics. So we get P of x, which is given to us as equal to x squared minus 3x minus 7. And we also get Q of x is equal to x squared. We'll let the x coefficient be a because we do not know that coefficient. But we do know that Q of 0 equals 2, so the constant term is 2. R of x is equal to x squared plus bx plus c, because we don't know any of these coefficients. They're not given to us except for the first one. And so now we just add up these. The next logical step would be to add these up, because the problem mentions p plus q, p plus r, and q plus r. So let me go into a new slide and sum them up. I don't know if I can copy these over. Well, yeah, I'll just write them here. So we can write that p plus q is equal to the sum of these two, so it'd be 2x squared minus 3x minus. Hold up, I made a mistake. Let me just erase that. So it's the sum of a and minus 3, so it would be plus a minus 3x, and sum of -7 and 2 is just -5, so that's -5. P plus r is also equal to 2x squared. If you get that, this is actually equal to plus b minus 3x. And we get this is plus c minus 7. And then we get q plus r. And q plus r is equal to, let me just divide this so I don't mess up. Q plus r is equal to 2x squared. And we sum those coefficients up, which is just plus a and b. So plus a plus bx and plus c plus 2. All right, so now we have those polynomials, and let me just write them down so I can transfer them to the next slide before we move on. All right, okay. So we know that each of these has a common root. So let me just rewrite them out. You can probably skip this part. It's just rewriting the polynomials that we had before. And so I'll just write these. Sorry for taking a bit of time. Writing with the mouse is hard. So it's 2x squared plus b minus 3x plus c minus 7 and q plus r. a plus bx, sorry about that, plus c plus 2. Alright, so we know that each pair of these has a common root. So let's call the common root of p plus q and p plus r, let's just call that root r. So we can just write like a roots table over here. We know that each quadratic has two roots just by definition. So we have p plus q has root r and p plus r has root r, so that's their common root. We let the common root of p plus r and q plus r be s. And we let the common root of this pair over here, p plus q and q plus r, be t. So now we have the three roots. So now what we can do here is we can actually express these roots with using Vieta's formulas. So if we actually write that out, we know that r plus t is equal to negative of the b coefficient, which is negative of the x coefficient, which is 3 minus a, over the coefficient of x squared, which is 2. And similarly for everything else, that would be r plus s equal 3 minus b over 2. And t plus s is equal to negative a minus b over 2. Similarly, we also have the product rules, which are rt is equal to negative 5. rs is equal to c minus 7. Well, negative 5 over 2. Sorry, I had to divide. So c minus 7 over 2. And ts equals c plus 2 over 2. So I'm just going to erase everything at the top here. So we have all these equations here. These are expressing the three roots that we listed over here in terms of the coefficients on the left. And the goal here is to find c, because c, as we defined, was the constant term of polynomial r. And if we can find c, then we will be able to solve the problem. So the first thing you look at is these three equations over here. They are pretty interesting. We have a 3 minus a 3 minus b, and then a negative a minus b. Adding or subtracting any of these equations may actually lead us somewhere. So we're going to look at manipulating these equations to see where we can get. So what I'm going to do is I'm going to erase the top here because we don't need it. We know we're just trying to solve for c at this point. Yeah, let me just erase that. All right. So now let's try doing this. So if we actually take this equation and this equation, this first equation over here and this third equation over here, and we subtract them, we actually get r minus s. R minus s will be equal to 3 minus a minus negative a minus b over 2. Note that subtracting those will actually cancel the a's. It actually gives us 3 plus b over 2, subtracting those two fractions. But we also know that r plus s is equal to 3 minus b over 2. This is extremely convenient because if we add them together, we cancel the b's and we cancel the s's. This gives us 2r equals 6 over 2 if we add these two up, which is 3. And it gives us r equals 3 halves. That's huge. Now we can solve, look at these equations over here, we can solve for t, and then we can probably do something here with these equations. So what we're going to do is I'm going to erase this because we know that r is equal to 3 halves. That's the key information we have. And let me just erase this stuff at the top. And r equals 3 halves. R equals 3 halves from the equation over here, RT equals negative 5 over 2, we can tell that T is equal to negative 5 over 2 over 3 over 2, which gives us that T is equal to negative 5 thirds. Let's probably fix that. Negative 5 thirds. So what that tells us is now we know R, now we know T, we can actually set S in terms of C. So over here we have that, since we know that R is equal to 3 halves, from the second equation over here, we have that 3 halves S is equal to C minus 7 over 2. That gives us that S is equal to C minus 7 over 2 times 2 thirds, which just gives us C minus, if we multiply this by 2 thirds and we multiply this by 2 thirds, these cancel and these cancel, so that just gives us that S is equal to 7 minus 7 over 3. And from the third equation over here, we know what T is, so this gives us that this is negative 5 thirds S is equal to C plus 2 over 2. So we just multiply by negative 3 fifths, and those cancel, and then times negative 3 fifths, which gives us that S is equal to negative 3C plus 6, no, minus 6. Oops, I can't multiply. So yeah, so negative 3C minus 6 over 10. So now we have S in terms of two different expressions that involve C. So now we can equate these and we can actually solve for C. So that's our final step in this problem, and we're approaching the final steps. So let me just erase this bottom part over here because we don't need it anymore. Let me just make some space for our following calculations. So now we can just equate this equation over here, this expression over here, and this expression over here, since they're both equal to S. So you get that C minus 7 over 3 is equal to negative 3C minus 6 over 10. Now we can just cross multiply. That gives us that 10C minus 70 is equal to negative 9C minus 18. And if we combine like terms, we get that 19C is equal to 52, which gives us that C is equal to 52 over 19. So 52 over 19 is in lowest terms. If we go back to what the problem was saying, we have R of 0, which is equal to C right here. It's 52 over 19. We just need to find m plus n. And that gives us that our answer is 52 plus 19 equals 0, 7, 1. And that's your final answer. Thank you for watching. If you enjoyed this video or if you thought it was helpful, please do consider liking and subscribing. It would help our channel a lot. And if you want to join our CNCM official Discord server, if you have any questions about any problems, we also have a problem of the day. We have a lot of cool stuff in the Discord server. The link will be in the description below. Thank you for watching.